All right, so we spent the last few days talking about parallel lines. Well, we're going to finish up this unit with a lesson here on perpendicular lines. And you pretty much know what you need to know about perpendicular lines. Okay, they form right angles, so they form 90-degree angles. And we're just going to go over a couple of things. One thing that we're going to do is we're going to construct a perpendicular bisector. So I'm going to put a segment here, and even if you don't have a compass, you can still mark your paper the way I'm going to mark my paper so that you know what the construction of a perpendicular bisector looks like. And we're going to practice it in class too. So here's a segment, and what I want to do is construct a perpendicular bisector. Now, there's a couple of ways I could do it, right? Bisector means split it exactly in half. So I could take the coordinates of these points and I could plug them into the midpoint formula, right? And I would find the midpoint right in here somewhere. Then I could find the slope, find the rise over run. I could flip and switch and figure out that it's from that point, start doing the slope. But that's a really hard point right there for me to start doing slope from, right? It's going to be hard to count up and over a certain amount when you're not even starting at a point. You're starting in between some whole number of points. So there's an easier way to do it, and it's with a compass. Also, this segment's not on a coordinate plane, meaning that there's no x and y axis in my picture. So I don't really know what the coordinates of this point are, right? I could figure out the slope though. I couldn't figure out the exact midpoint. So I'm going to use a compass. And you know that a compass makes circles. So if I put this compass on here, right? And if I put it lots of different places, right? Put it here, here, here. I think the middle is right about there. But let's say I put it way over here on the side, okay? And you just follow along here. Say I drew a circle, right? And then I come over here, and my circle went a little crazy there, but that's okay because I'm going to erase it anyways. And I drew another circle. Well, the midpoint's still right in here somewhere, right? So I drew these two big circles, and it pretty much did me absolutely no good, right? But what if I could take those two circles and make them intersect each other, which apparently the computer's not going to let me do. What if I could take this circle and make it a little bit bigger, and then make this one a little bit bigger? Wouldn't they cross somewhere here? And they'd cross somewhere here, right? So I'm going to get rid of these circles for a second. I'm going to go back to my compass. So what if I made the compass stretched out farther than I know the midpoint is, right? I don't know where the midpoint is, but I know this is farther. And I'm going to make my big giant circle. But instead of making the whole thing, right? I mean, I could make this whole big circle like this. But do I need all this stuff out here? What I really need is that piece there, and probably that piece there. Then I'll take my compass over here, put it on this point, right? And again, I don't need all this stuff out here. All I need is right there. And right there. If you saw, I kind of missed on that one, right? I didn't get it good, but I can take my compass back over here and just extend that out a little bit more, right? So I kind of got my spot that I need. So that's where those two circles would have intersected, right there and right there. So I'll take my line tool and I'll draw my line that goes in between those 2 points. I'll label it, put my arrows on it, and now I've created a perpendicular bisector of this segment, and these 2 green pieces are exactly the same length. I'm right in the midpoint, I'm perfectly perpendicular, and I didn't have to do any calculating, I just used a compass. So we're going to practice that in class more. The next thing that I want to talk to you about perpendicular is, I want you to think about your room. Maybe you're in your room right now, maybe you're not in your room, but think about your room. So let's say that this rectangle is your room. Well, in your room, you've got things, right? You have a door. Hopefully, you have a bed. You might have a dresser. You might have a chair or a couch or something like that. But here's your room. Now, if I told you right now, if I said, I want everybody to measure the distance from their bed to the wall behind it. So from the bed, from the headboard to the wall, I want to measure how far that is. Or if I say, I want you to measure from the foot of your bed to the opposite wall. Let's say we're going to measure from the foot of the bed to the opposite wall. And I said, I want you to bring that measurement to me to class tomorrow. We're going to do a little project. How many of you would go to the foot of your bed right here and start measuring like that? How many of you would go to the foot of your bed and measure like that? I'm hoping none of you. All of you should go to the foot of your bed and measure like that. And if I asked you to describe, if I said, how did you measure it? You would say, I measured it straight. Right? I went straight to the wall. Well, this dotted line is straight. And this one is straight too. It's at least as straight as these because I drew them all freehanded. So straight is not the word that we need to, the connection we need to make here. What you should say is that you measured it perpendicular to the wall. Okay? And the reason that that's important is when we start talking about perpendicular, I'm going to draw a little triangle here to illustrate my point. So here's a triangle. I don't know anything special about this triangle except that it is a triangle. It's going to have a height, right? And the height is perpendicular. And maybe this will be triangle A, B, C. And then this point right here will be point D. Now, I don't know how long A to B is. I don't know how long B to C is. And I don't know how long B to D is. But I do know, no matter what, that A to B is always going to be greater than B to D. And I know that B to C is always going to be greater than B to D. Right? Does that make sense? This side has to be bigger than this, right? Just like over here, the shortest distance between your bed and the wall was the perpendicular distance. Right? Not the straight line, because they're all straight lines. And the shortest distance from B to AC is the perpendicular distance, not these. So an example of how this is going to be used, or what you might do with this, just a real quick example. We'll take this triangle, tweak it a little bit so it looks kind of weird. We'll spin it around. So I have this triangle. Now, you might have a problem. Say this is perpendicular. Hopefully it is. So this is my perpendicular distance. You might have a problem that says that this is 8. This is 23. I don't know how long this is. It doesn't matter. And this is the height. And the question would say, write an inequality for the height of my triangle. Well, I don't know what the height is, but I do know that the height is going to be less than 8. Okay, and we're going to throw some algebra into it. It's going to make it a little harder, but that's the basic idea. I don't know what the height of this thing is, but I know it's less than 8. Right, the last thing that we're going to write down, the last thing that we're going to talk about is there are 3 theorems in your book in chapter 3, section 4, which is what this perpendicular line stuff relates to. And one of the theorems is called the perpendicular, oh, that's awesome, right? Good handwriting. Transversal theorem. Okay? And what we're going to do is prove the perpendicular transversal theorem. The other 2 theorems don't have a name, but you still need to know them, and you need to be able to shorten them to describe them. And it shows you exactly how to do it in the book. So you need to look that up and make sure you can do it. The perpendicular transversal theorem says if a transversal is perpendicular to one of 2 parallel lines, then it is perpendicular. Perpendicular. This is the 6th video I've made today. I'm getting tired of writing. It's perpendicular to the other line. Right? Halftime of the Texans game, so I gotta hurry. My fish sticks are almost done. Perpendicular to the other line. Now, that's a theorem. So we're going to try to prove it. So we need to write down what we know here. This is a theorem, and it says that a transversal is perpendicular to one of 2 parallel lines. So that is your given information. So I'm going to draw what that looks like. So here is transversal. Right? That is perpendicular to one of 2 parallel lines. Now, this transversal will be T, this line will be L, and this line will be M. Those are just random letters I picked. If we wanted to do the proof, which you want to be able to do, right? We want to get better at this. We want to talk about what is our given information. Well, the hypothesis is the given information. So a transversal is perpendicular to one of 2 parallel lines. So that means it's given to us that L is parallel to M and T is perpendicular to L. So that's a transversal is perpendicular to one of 2 parallel lines. Then, so we're going to prove, then it is perpendicular, so T is perpendicular to the other line. So I want to challenge you to try to do this yourself right now. Okay? We'll go over it in class tomorrow, but remember how to do one of these. You start out with a plan. I know that they're parallel, and I know that this intersection right here is perpendicular. I need to show that this one's also perpendicular. And I've learned some things about parallel lines that are cut by transversals and the angles that are formed, right? I've learned some things. So try to articulate it and try to logically step yourself through it. You're not going to be able to just say, oh, well, that's perpendicular, so that's perpendicular, because the lines are parallel. There's reasons for all of it, right? Perpendicular means something. The fact that these lines are parallel tells us something about these angles. Try to put all that together in a logical sequence. It shouldn't take you more than, I'm saying maybe 5 or 6 lines, but see if you can do it yourself, and we will talk about it in class tomorrow. Good luck.